Okay, so I'm out today, so you're going to need to pay attention to the video, make sure you take all the notes so that you can work on the assignment, be ready when I get back. So today you're covering 3 sections, 10.1, 10.2, and 10.3. It's arcs, angles, and chords. We're starting our circle unit, so there's a lot of things about circles that you already know, and we're just going to add to it. All right, so what we're going to do is we're going to look at definitions of lines and segments that intersect circles, because there are lots of special properties with the angles and the segments themselves. We're going to identify special segments. We're going to use the properties of tangents. So I know we've seen this word when we were doing trig, but it's actually a line. We're going to find arc measures, and we're going to use chords of circles to find lengths and arc measures. All right, so what is a tangent line? A tangent line touches the circle in exactly one place. So if you look over here, so a tangent line, so notice how this line right here, and we're going to put another point right here. Let's just call this point X. So line XA, so line XA, it touches the circle in exactly one place, so therefore it is a tangent line. The point where it is touching the circle is called your point of tangency. So point A would be your point of tangency. That's where it's touching exactly. So it's just like sitting on top. A secant line intersects the circle in exactly 2 places. So for example, EB. So EB would be a secant line. Okay. So radius, obviously the radius starts at the center and goes to the edge. So in this picture we have 2. We have SC and we have SD. The diameter goes from one edge of the circle to the other, and it goes through the center. So DC would be my diameter. A chord is any segment in a circle that has 2 endpoints on the circle. So like DC is a chord, EB is also a chord. So it's a secant if it goes through, and it's a chord when it stops. All right. So now looking at this picture over here, let's name all of, let's name all of these things we've got over here. Please keep in mind there is more than one answer. Okay, so it says to name 2 radius, so 2 radii. So AD would be a radius. AF would be a radius. AB is also a radius. So even though it said to name 2, there's all of them. A chord would be EC. EC is a chord. And ED. So ED is also a chord. Remember, it just needs 2 endpoints on the circumference. Name a diameter. DF or FD, however you want to name it. DF or FD, order doesn't matter. A secant is a line that goes through, so it goes all the way through the circle. So I would say line ED. A tangent line is one that touches it exactly in one place. So let's put a point here, and let's call this point G. So now we've got tangent line BG, and it's touching the circle at point B. So point B is your point of tangency. It's pretty easy, basic stuff, but you do need to know what the terms mean, or else solving the problems could get a little tricky. All right, so tangent line theorems. There are some actual theorems that go with tangent lines. So let's look at those. The first one is line M, so this line right here, so this tangent line. It's tangent to circle Q. You name circles by their center. If and only if the line is perpendicular. So if you see a line touching a circle and it's perpendicular to the radius or the diameter, then that means it's tangent. So for example, the measure of angle QPS, so QPS equals 90 degrees. This one says is ST tangent. Well, in order to find out if this is tangent, so I want to know if this is a tangent line, the only way to find out is to determine if this angle right here, if angle T, is a right angle. Well, the only way to determine if it's a right angle is to check and see if STP is a right triangle. So I would say if triangle STP is a right triangle, comma, then, so write your conditional statement, then ST is tangent. I'm going to spill over here. So the way to check that is 12 squared plus 35 squared. Is it equal to 37 squared? So we get that those two add up to 1369. That one is 1369. Since it is equal, then yes, this is a right triangle. So that means that ST is perpendicular to TP. All right, so over here, it says in the diagram, point B is a point of tangency. So since this is a point of tangency, then that means that is a right angle. So that means I've got to figure out what R is. So let me change the color of my ink so we don't get the two problems mixed up. This is your hypotenuse. Okay, so this is R plus 50. Okay, this is your hypotenuse. This is side A, this is side B. We're just going to do good old-fashioned Pythagorean theorem. So A squared plus B squared equals C squared. Well, A is R, so R squared, plus B is 80, and C is R plus 50 squared. So here, we're going to have to go through and do some FOIL. So we got R squared plus, well, 80 squared is 6,400. And now we've got to do R plus 50 times R plus 50. So remember how that looks. R plus 50 times R plus 50. So you got to go first, outside, inside, last. You got to double distribute. You get R squared plus 100R plus 2,500. So now, if I subtract R squared from both sides, it beautifully cancels out. I'm going to subtract 2,500 from both sides. So if I subtract 2,500 from both sides, I get 3,900 equals 100R. Divide both sides by 100, and I get that the radius is 39. So that's what they wanted. It said define the radius. So the radius is 39. So don't forget, basic algebra 1. Got to know how to do it. All right, then there's an external tangent congruent theorem. This one's the easiest one of them all. It says if SR and ST are tangent, so see how R is a point of tangency, T is a point of tangency. So I have tangent line SR and tangent line ST. Okay, if they're tangent from the same exterior point, then these two are congruent. So like R is an external point, S and T are points of tangency, then that means this is congruent to this. So 3x plus 4 is equal to 28. 3x equals 24. Sorry. And then you divide both sides and you get that x is 8. So Find the value of x. Done. Circles are really easy, so try not to get too stumped up over them. All right, so now let's talk about arcs. An arc, it's a part of the curve. Okay, so it's a part of the curve. It's kind of like if you think about its shape is like an arc, kind of like an eyebrow. It's just a slight curve. The measure of this arc is equal to the measure of this angle. So this is a central angle because it's coming from the center. So that's going to be 50 degrees. So let's talk about all these different measures. So the measure of the entire circle, well, there's 360 degrees. The measure of a semicircle, which is half, is 180 degrees. ACB is a central angle because the vertex is at the center. So vertex is at the center. AB is a minor arc, so this is a minor arc, AB, because it is less than 180 degrees. The measure of the minor arc is the measure of its central angle. Now, ADB, so ADB is major because it's bigger, so major, bigger, like a major problem is a bigger problem. And you have to have 3 letters. The first letter is where you start, the second letter is, or the third letter is where you end. The second letter tells you the direction to go around the circle. So you're going to go from A around to D, then around to B. And this is major because it's greater than 180 degrees. So it's greater than 180 degrees. So for example, if this angle is 50, then this angle is 360 minus 50. So it's 310 degrees. So the measure of the major arc is 360 minus the minor arc. Pretty basic stuff. Again, I think you'll catch on pretty quick. All right, so let's identify, is it major, minor, or semi? And in order to do that, I've got to know the measures of all of them. So what I'm going to do is go through and find everything that's missing and then go from there. So first of all, since AC is a diameter, that means from here to here is 180 degrees. Well, if this is 40, then this is 140. Okay. All right, so let's go from here. It's really not, it's not telling me. It should have told us that this is 90. So if that's 90, this side is 90 as well. So this is a radius that's cutting the semicircle in half. So just remember that the measure of the angle, since it's a central angle, is the same measure as the arc. So this is 90 degrees, this is 90 degrees, this is 40 degrees, and this is 140 degrees, and I just caught this here. AC is perpendicular, so AC is perpendicular to BE. Totally missed that. All right, so here we go. First thing we're going to do is all of these are supposed to have arcs over them. I apologize. When it printed, it left off my arcs. So go ahead and put arcs. Just like if it was a segment, we'd put a segment. If it was a line, we'd put a line. If it was a ray, we would put a ray over the top. You have to put the symbol. The symbol is extremely important. All right. So AB. So they're talking about this arc right here. So AB is 90 degrees. Therefore, it is minor because it is less than 180. ABC. A to B to C. This is 180 degrees, and this is a semicircle. ABD. So now A to B all the way to D. So that's going to be 180 plus 40. So 180 plus 40, is 220. So that makes it major. BC is 90. So that makes it minor. BAC. B to A all the way to C. Well, it's basically the whole circle except for that one arc. So I could do 360 minus 90, or I could say, well, it's all of this. So 360 minus 90 is 270 degrees, which makes it major. DAB, D to A to B. Well, D to A is 140, and A to B is 90, so that's 230 degrees. Again, major. AD is this part right here from A to D, and that's 140 degrees. This would be minor because it's less than 180. And then CD is this little arc right here, 40 degrees. It is also minor. So pretty easy. It says in circle E, so in the circle up here, tell whether arc ABC, so again it left off the arc, is congruent to ADC. Explain why or why not. Well, ABC, so A to B to C is a semicircle, so that's 180 degrees. ADC is 180 degrees. So yes, the arcs are congruent, and it's because AC is a diameter. So it splits the circle in half. So let's look at this one over here. It says find the value of x. Well, what do we know? Well, I know that all the way around, it's supposed to be an arc. I know that all the way around is 360. So if I add all of these four things up, it's going to equal 360. So 5x plus 40 plus 70 plus 75 plus 2x equals 360 degrees. So add your like terms. 7x plus 185 equals 360. Subtract. 7x equals 175. Divide. So x is 25. So x is 25. Now it says to find the value of x. Check. Found it. Find the measure of arc AB. Well, arc AB is this arc right here. So AB is 5x. So that means 5 times 25. So 125. So the measure of the arc is 125 degrees. Which now I could find the others too. So that would be 125. And we got 70, 40, 125. Well, add them all up, subtract from 360, and you can get this one. All right. Now we have some chords. Remember, chords have two endpoints that lie on the circumference of the circle. First one is called the congruent corresponding chord theorem. It says if you're in the same circle, or if you have congruent circles, that two minor arcs will be congruent if and only if their corresponding chords are also congruent. So for example, if this chord is congruent to this chord, then this arc will be congruent to this arc. So if AB is congruent to CD if and only if AB is congruent to CD. And then you have one, it's called the perpendicular chord bisector theorem, and its converse. So if a diameter of a circle is perpendicular to a chord, so if the diameter is perpendicular to the chord, it bisects the chord, so this is congruent to this. It also bisects the arc, so that arc will be congruent. So if EG is a diameter, and EG is perpendicular to DF, then HD is congruent to HF, so segments, and G, so we're going to say, and DG is congruent to FG, and these are arcs. So, so if this is perpendicular to this, then you get two things that are congruent. The converse just says if one chord is perpendicular to another chord, then the first chord is the diameter. Equidistant chord theorem, if you have the same circle or congruent circles, two chords are going to be congruent if and only if they're equidistant from the center. So if this piece is congruent to this piece, equidistant meaning same distance. So if EG is congruent to EF, then CD is congruent to AB. So AB is congruent to CD if and only if EF is congruent to EG. So now let's put these to use. All right, so find the measure of the arc or chord. So this is an arc, left it off again. This is a segment. This one is a segment, and this one is an arc. So I know for a fact that if this is 3.6 and this is 9.2, this is 42 degrees, this is 42 degrees. So this one is also going to be 3.6. So ZY is also 3.6. WZ, which is going to be 9.2. Let's see, arc WX. WX is this arc right here. It's going to be the same as this angle, which is the same as this angle, which is 42 degrees. And arc XY. XY is going to be this one over here. Well, I know that this ZX is a diameter. So if this is 42 degrees, then 180 minus 42 is 138. So that makes this angle here 138 degrees. Okay, here we have a diameter, and it is perpendicular to a chord. So that means this is congruent to this. So 2x minus 4.1 is equal to x minus 0.5. Subtract x, I get x. Add 4.1 and I get 3.6. So x is 3.6. It's all pretty basic, but if you're not paying attention, you can get lost. All right. I think I'm missing a piece. Nope, there it is. Okay. Find the radius. So they want me to actually find the radius. Well, remember, the radius goes from the center to the edge, but they don't have any radius drawn. So what I'm going to do is draw my own radius since they didn't actually give me one. The radius is the radius. It doesn't matter. So I'm going to call that my radius. They're telling me that WX is 20. Well, that means this is 10, and that means this piece is 10. And I also know that since this chord is congruent to this chord, then that means this is congruent to that. So that means that 4x minus 5 is equal to x plus 4. So if I subtract x, I get 3x. And if I add 5, I get 3x equals 9. So x is 3. Well, if x is 3, 3 plus 4 is 7. So that makes this piece 7. Now think about, you've got this triangle right here. Do y'all see triangle WOZ? Well, this is 10 and this is 7. Can I do Pythagorean theorem to get my hypotenuse? So 7 squared plus 10 squared equals the radius squared. 49 plus 100 is 149. And that equals r squared. Oops, I left it off there. I've got to take the square root of both sides so that I can get r. And I get 12.2 for my radius. So that means this piece right here is 12.2. And that's all you have to do. So now that you're done with the notes, we're going to cover them one more time when I get back. And you have your assignment to work on. Please stay busy, and I will see y'all next time.